Hello friends, welcome to our channel Engineering and Technology for You. In today's video, you will learn 8086 addressing modes. Let us start with the introduction. An instruction is divided into operation code, that is opcode, and the operands. The opcode is a group of bits which indicates what operation can be performed by the processor. And an operand is known as datum or data, and it can identify the source and destination of data. The operand can specify a register or a memory location in any one of the memory segments or IO ports. Here you must understand that there are 4 memory segments in 8086: the code segment, the data segment, extra segment, and the stack segment. So accordingly, that has to be specified. Then there are different ways to specify an operand. Each way of how an operand can be specified is called addressing mode. So addressing mode is nothing but the way in which the operand is specified. There are different addressing modes of 8086 microcontroller. There are immediate addressing, register addressing, then memory addressing, branch addressing. Now we will see the details of these addressing modes. First comes the immediate addressing. In this addressing mode, the 8-bit or 16-bit operand is a part of the instruction, and it will immediately follow the opcode. So if you take the examples, move AL05. Now here 05 is the data and AL is the register where it is to be loaded. So this will load 05 in AL register. Then next, if you see the next instruction, move BX 6000H. Now here the BX register is a 16-bit register, and hence the operand is also 16-bit. So we have given here 6000H. So this instruction will load 6000H in BX register. So BX register, as you know, it consists of BL and BH. Then the next instruction is move SP 3000H. Again, SP is a 16-bit register. That's why this will load 3000 in the stack pointer register. So immediate addressing can be used for all the registers of 8086, which can be loaded directly, except the segment registers. They cannot be loaded directly. Then comes the register addressing. Now in register addressing, the operand is a place in one of the 8-bit or 16-bit registers. So the operand will be placed in the registers. Now all the 8-bit registers, that is AL, AH, BL, BH, CL, CH, DL, DH, and all the 16-bit registers AX, BX, CX, DX, then ESI, source index, destination index, stack pointer, and base pointer. So all can be used here in this addressing except instruction pointer. So that is the only limitation. Then the only restriction is that both operand must be of the same length. So when we are using this addressing mode, we should be careful about the operands. Now if you see the examples, first example is move AL, BL. Now here both the operands are 8-bit. So BL is 8-bit, AL is 8-bit. So this is a valid instruction. So it will copy the value from BL to AL. So this is the source, this is destination. Then next is move AX, BX. Here both the operands are 16-bit. So it will copy the value of BX to AX. Then next, move DS, AX. We will copy the value from AX to DS. Then move SI comma DI, copies the value from SI to DI. So here only restriction is that both operands must be of the same length. Either it is 16 bit or 8 bit. Then only it will be a valid instruction. Then the next addressing is memory addressing. Now memory addressing requires determination of physical address, because all of you are aware that the 8086, the physical address is 20 bit, because it has got 20 address lines, and the segment registers, they are 16 bit. So the physical address can be computed from the contents of segment register and an effective address or offset. We have already discussed this, how to calculate the physical address, in the previous lecture, that is on physical address and memory segmentation. The segment address identifies the starting location of the segment in the memory, and effective address represents the offset of the operand from the beginning of the segment. So this is what you will have to remember always. The offset will be the effective address that will represent the offset, and the segment address that will give the starting location of the segment in the memory. Then memory addressing has the following combinations. First is direct addressing. Then we have the register indirect addressing, register relative addressing. Here this addressing mode, in some of the textbooks they have separated it as based and indexed. So you have to be careful when you are studying this. Then next is index addressing. Then we have the base index addressing, then base index with displacement addressing. Now here maybe this also is combined here with the register relative addressing. Then direct addressing. Let us see the direct addressing in details. Now in direct addressing mode, a 16-bit memory address, that is offset, is directly specified in the instruction as a part of it, and the 16-bit effective address is taken from the displacement field of the instruction. So the displacement may be 8 or 16 bit. It is stored in the location which follows the instruction opcode. So whenever we are giving this type of addressing, the opcode will be followed by the displacement. The displacement will be followed by this after opcode. So their effective address is 8 or 16 bit displacement, and the physical address, PA means physical address, that will be segment multiplied by 10H plus the effective address. So already we have taken certain examples on this in the previous video. Those who have not watched my previous video, they can watch the details in the physical address and memory segmentation. Then here let us take an example. Move AL DS colon 2000H. So here DS is the segment and 2000H, that is the offset. So we have taken the value for DS as 5000H. So physical address will be DS into 10H plus 2000. So that will be 5200H. So the instruction move AL comma DS colon 2000H, what it will do, the contents of memory location 5200H loads into AL. So they are loaded into the AL register. So this is how the direct addressing will work. Then let us go to the next, register indirect addressing. Now 8086 allows us to access memory indirectly through a register using register indirect addressing. In this addressing mode, the effective address EA may be taken from one of the base or index register specified by the instruction. So here either you can use the base register or the index register. The BX, SI or DI register use the DS segment by default. and the BP, that is the base pointer, uses the stack segment by default. So this is also important. You should know the default segments for understanding the addressing modes. Now the effective address will be BX or BP or SI or DI, any of these, one of these, and the physical address will be segment multiplied by 10H plus E. So if the segment is DS, it will be DS multiplied by 10H plus E. Now let us take the examples. Here move AL comma BX. Now in this case BX is the register and the effective address will be the contents of BX, and whatever is the content of DS, that is the data segment, it will be multiplied by 10, and then these contents of BX are added, and that will give us the physical address. Then similarly here the contents of SI will be added as effective address. Then the last, move AL BP. Here the contents of BP, they are added. Now in this case the default segment will be SS, so that will be added to the segment SS multiplied by 10H. So this is how the register indirect addressing will work. Then we have register relative addressing. Already I have mentioned that here this is, in some of the books they have mentioned it as base address and index addressing. So that is, if you are considering here all the registers BXSP, then it will be same. In this addressing mode, the data is available at an effective address form by adding an 8-bit or 16-bit displacement with the contents of any one of the registers. Now here BX, BP, SI and DI, we are considering all the 4 registers, that is 2 base registers and 2 index registers, and the segments DS or ES can be considered. So that's why the register relative addressing, it is, some of the textbooks have taken it separately as base addressing and index addressing. So it is again the same thing. Now let us take example. Move AL 50 BX. Now here the base register is taken. Now let DS is equal to 2000H and BX is equal to 0100 100H. So effective address will be BX contents plus 50H, that will be 150 0150, and then physical address when you are calculating, so DS multiplied by 10H plus EA, so that is going to give you 20150, so that will be 20150. So the contents of memory location 20150, they are copied to AL register. Move AL comma this is given. So when we are giving the instruction, here we are just giving the base register, and the contents of base register, they are 0100, so they are added with this 50, and then the physical address will be calculated. So we get the physical address as 20150 because the DS is 2000. Then let us go to the next, base index addressing. Now here in this addressing, the effective address of the data is formed by adding contents of base register BX or BP to the contents of an index register SI or DI. The default segment register may be ES or DS. Now again we are taking the similar example, move AL BX SI. So it is both the base register and index register is taken here. So again we are taking DS is equal to 5000, BX is equal to 1000, and here SI is 0020. Then EA is equal to BX plus SI, so that will be 1020, and physical address will be DS into 10H plus EA, so that will be 51020. The contents of memory location 51020 are copied to the AL register. Then let us go to the next, base index with displacement addressing. The effective address is formed by adding an 8-bit or 16-bit displacement with the sum of contents of any one of the base registers and any one of the index registers in the default segment. So here base, index with displacement, all three are combined. So if you are taking example, move AL 50H BX SI. Now again let DS is equal to 5000H, BX is equal to 1000, SI is equal to 0020. So the BX, that is the base register, is combined with the index register, and that is again the displacement is added to that. So that gives us the effective address 1070H. Then physical address will be DS multiplied by 10H plus this effective address. So that will come out to be 51070. So the contents of memory location 51070, they are copied to the AL register. So this is combination of base, index with displacement. Then let us go to the next, that is the branch addressing. Now for branch addressing, the control transfer instructions, the addressing modes depend upon whether the destination location is within the same segment or in different one. So here the modes of control transfer, they are separated into intersegment and intrasegment. And again the intrasegment is divided into direct, indirect. Say that is intrasegment direct, intrasegment indirect. Here again it is intersegment indirect, intersegment direct. The intrasegment mode is used to transfer control to a destination that lies in the same segment. That's why it is called as the intrasegment. Whereas the intersegment mode is used to transfer the control to a destination that lies in different segment where the control transfer instruction lies. So when we are changing the segment, then we call it as the intersegment. Then how we change the segment, that is, with that we have the intersegment direct, intersegment indirect. And if it is in the same segment, we have the intrasegment. So again direct and indirect. Let us see these addressing modes in details. First is intrasegment direct. Now in intrasegment direct mode, the address to which the control is transferred lies in the same segment because it is intrasegment. Then where the control transfer instruction lies and appears directly as a immediate displacement value. So it is intrasegment direct. So it will appear directly in the instruction as a displacement value. So the effective branch address is the sum of an 8-bit or 16-bit displacement and current contents of IP. So when we want to branch, we'll have to take the current contents of IP plus the displacement. So the effective address will be IP plus 8 or 16-bit displacement. So you can see the figure. IP and displacement, they are added, and that gives us the effective address. So here, if you are considering the jump instruction, if the signed displacement is 8-bit, So it is called as the short jump. So if the sign displacement is 8 bit, that means the range will be minus 128 to 127. So that will be the range for the signed 8 bit numbers. So that's why it is called as the short jump. And if the sign displacement is 16 bit, it is called as the long jump, because the displacement will be minus 32768 to plus 32767. So that is 16 bit displacement. So this is the intra-segment direct addressing. The displacement IP, they are added to form the effective address, and that will be combined with the code segment to have the physical address for the jump instruction. Then next is intra-segment indirect. Now here in this mode, the control to be transferred lies in the same segment, because it is intra-segment where the control instruction lies and is passed indirectly to the instruction. So you can see here, indirectly it is passed, and the effective branch address is found as the contents of register or a memory location that is accessed using any one of the data related addressing modes except the immediate addressing mode. So whatever addressing modes we have studied, they are used here. So the addressing mode, depending on the addressing mode, the effective address is computed according to the addressing mode, because that will calculate the effective address for the memory. And then this is the effective branch address for register, or it will give effective branch address for the memory. So the contents of IP are replaced by the effective branch address. If it is register, whatever is the contents of register, that is replaced here. Contents of IP are replaced by that. Or if it is memory, the contents of memory location, the IP is replaced by that effective branch address, and the jump will take place accordingly. So that is intra-segment indirect addressing. Then next we have the inter-segment direct addressing. Now in this mode, the address to which the control is transferred is in different segment, because it is inter-segment, and this addressing mode provides a means of branching from one code segment to another code segment. So we can branch from one code segment to another code segment using this inter-segment direct addressing. The CS and IP of the destination address are specified directly in the instruction, as you can see here in the figure. This is the instruction. So the offset and the segment both are given in the instruction. So the segment address will be given to the code segment, and offset address will be given to the instruction pointer IP. So for example, here jump 5000 colon 2000. So this 5000, that is the segment address, and 2000 will be the offset address, and the jump will take place. The same physical address we'll have to calculate, so it will come out to be 52000H, and directly the jump will go to that place. The next, inter-segment indirect, that is the last addressing mode. Again it is inter-segment, that means the location to which the control is to be transferred is in different segment and is passed to the instruction indirectly, because this word is there, it will be passed indirectly. That is, it places the contents of the IP and CS with the contents of 2 consecutive words in memory or 4 bytes in memory. The starting address of the memory block may be referred using any of the addressing modes except the immediate and register addressing. So here whatever addressing we are using for the data, so according to that we'll do the calculations. So EA computed according to the addressing mode. Maybe we may use the base index or register indirect or any other addressing here. So ultimately what we are going to get, we'll get either 2 consecutive words in memory or 4 bytes in memory. That is same thing, 2 consecutive words or 4 bytes. So whatever 2 consecutive words in memory, so that will be taken as segment address and the offset address. Say for example here we have taken jump 2000H. Now here only we have specified the 2000H, that is the address given. So as per the value of DS, the calculations will be done, and whatever is the contents of that location. So if you are taking DS as 5000, so 52000, so 4 52000, 01, 02 and 03. So these 4 locations contents, they will be taken and then that will be given to the CS and IP. So CS and IP, and whatever address comes out, so the jump will take to that place. So that is how the inter-segment indirect addressing is there. So with this we come to the end of this video. If you like the video, please press the like button and share with your friends, and subscribe to our channel Engineering and Technology for You. And if you want to get notified, press the bell icon. This is very important. Subscribe the channel and press the bell icon, because whenever we are uploading new videos, directly you will get notified if you press the bell icon and subscribe to our channel. Then if you have any questions, now this 8086 is a bit difficult topic. You find you have any doubts, you can write it in comments, and or you can contact me on Facebook, then Twitter or Gmail, Ulhaskumar Gokhale @Gmail. You can directly mail your queries to me, and on Instagram. Then thanks for watching. Have a nice day.